Hi everyone. Thanks for joining in today. I am Deepika. I lead the AIML for Honeywell for the Smart Buildings division of Honeywell. I'm the director of AIML here. So today I'm going to talk about strategies for AI adoption at scale. So there is no doubt that AI has today gone mainstream. So there are many ways in which AI has touched our lives today. We use voice assistants like Google Home, Alexa, and many others on a day-to-day basis. And we extensively use video analytics for surveillance, for security purposes, be it at home or outside of our homes, etc. And now that remote operations, especially post pandemic, has become imperative, we use machine learning for IoT, for machines, remotely operating and remotely monitoring the machines and equipment and devices, again, at home, outside of home, wherever we are, right? So there are many ways and examples where automation also has come into picture using robots, and robots use AI at the core, right? So many of these techniques, if you see on the left hand side, the diagram shows some of these techniques, which are machine learning, natural language processing, deep learning, expert systems which use speech recognition, robotics, computer vision, and many such techniques. And all these fall under the AI bucket, right? So now that we all understand that AI has gone mainstream, there are many challenges in scaling up AI systems today. The first one being data quality itself, because without data, there is no AI, right? So the first challenge with respect to data that we see is the bias. So we have seen many such challenges, especially in cases like facial recognition, where the AI system is not able to recognize certain faces of a certain skin color or maybe a certain race, gender, etc. So that is because of the bias that exists in the data that AI systems have been trained on. So if there is not enough representation of every class or of every probably gender and race and skin color, etc., then the AI system, the facial recognition system, will not be able to learn those examples. And that is where unbiased data for training becomes extremely critical. And then we have yet another challenge with respect to outliers. So, in many applications, the definition of outliers itself changes, right? So, it is important to understand what an outlier is for a certain domain for which we are working with the data, and remove these outliers, treat those outliers in the right manner. So, this is a very common problem that we see in data. And yet another problem is with respect to the noisy data or unclean data, where we have a lot of missing values, data which is out of range, and things like that, right? So, especially when we collect data from remote places, then there is always a communication glitch, and we see a lot of missing data in such cases. So, these are some of the day to day challenges that we see with respect to scaling up AI systems when it comes to data quality. So, for operationalizing AI at scale, what does it take? So, there has been a framework called CRISP-DM, which is an age-old framework but has stood the test of time and is relevant even today. It is called CRISP-DM, which stands for Cross-Industry Standard Process for Data Mining. So this defines the complete end-to-end data life cycle, right from the gathering or collection of the data up to the deployment of AI systems, which use data analysis. So it starts with saying business understanding, right? So once we collect the data, we need to understand the problem, the business problem that we are trying to solve, right? So understanding the domain becomes very important there. And then comes the data understanding. So the next question to ask is, do we have the right data in order to solve the problem, the business problem that we are trying to solve, right? If not, we may have to go back and collect the relevant data which would be absolutely required for solving that business problem. And then we have the data preparation stage, which is more of the data cleansing, data pre-processing, etc. So in this stage is where we look at removal of outliers, treating the data which is noisy, removing the missing values, interpolating the data, and there may also be data from multiple sources. So we'll need to extract the data from all those sources. Um, Yeah, so in the data preparation stage, once we prepare the data, once we have cleansed the data and prepared it for further analysis, that's when the modeling phase starts. That is, this is the core of the AI systems, which is all to do with the development of the algorithms, analysis of the data, and maybe even visualization. So there is also a visualization layer which comes in after the modeling stage. And then there is evaluation, where we look at the accuracies of the models, we look at the error, we look at precision and accuracy and various other metrics, which tell us how efficient the algorithms have been in learning the data, the patterns, the underlying patterns of the data. And then once we are satisfied with, say, the accuracy values, we deploy the systems in real life. And this deployment doesn't stop at just once deploying those models. Right? There is also a need for retraining the models, especially machine learning models, as and when we receive more and more data. So this continuous learning of the models is also an important criterion when it comes to deployment. So on the right hand side, you see a diagram which depicts what it takes in order to scale AI systems in a real world. Right. So if you look at the picture, there is one small little box in black which says ML code. Right. It's the smallest box. So, which means that it is to say that the underlying models is just one part of the AI system, although that is the core. But the surrounding infrastructure is very complex, and it is absolutely necessary for any success of AI systems. So, if you look at all the other boxes, they say configuration, data collection. So, like I said, without data, there is no AI. Feature extraction, which is to do with all the extracting out the relevant features for the analysis, data cleansing, etc. And we also need process management tools, more like the versioning tools, machine resource management, the infrastructure, the compute, like the cloud or the edge, in compute infrastructure, the data verification. So making sure that the quality of data is good, analysis tools, the infrastructure and monitoring. So monitoring would also include the continuous, the CI/CD pipelines, the continuous learning of the AI systems, etc. in real world. So yeah, the gist is that ML code is just one part of the entire ecosystem of AI, but the surrounding infrastructure is quite complex. So this is just another video which kind of gives a very good picture of how the entire end-to-end pipeline for the data and AI systems work. So there may be multiple data sources, like I said, and then we have to extract and transform and load all these into one common data loader or data source. That's where the data lake comes into picture, where all the data is stored, and then the raw data is pre-processed and then prepared for the analysis. And that is when all the analysis, ML development, the data visualization, and the CI/CD for AI can begin. So there are multiple skill sets which are required for success and value derivation from data. Right? So data scientists are at the core of the algorithm development, but that is not, like we saw earlier, that is not the only part of AI. We also need, we of course need data scientists who mostly develop the algorithms, the machine learning algorithms, and who come with a background in statistics, math, programming, and are comfortable with tools like Python, R, and SQL. But the infrastructure, like the cloud infrastructure, the ETL infrastructure around the algorithms which are required actually for the development and deployment of the algorithms, that is where data engineers come into picture. So they come with a skill set in big data and cloud, and mostly take the decisions on the architecture, on how data needs to be stored, processed, and the analysis needs to be done, computed, etc. Right? So distributed computing, Python, cloud, these are mostly the skill sets of data engineers. And then we have data analysts, which are more like business analysts who translate the insights or the value from data into probably a suitable language that is consumed by any layman or the business users, right? So they mostly come with skill sets like SQL, Excel, and Tableau, especially for data visualization and business intelligence. And then we have yet another very important aspect today, ML Ops. Now, ML Ops stands for Machine Learning Operations. Since we have seen that AI is being deployed extensively in real world systems today, so scaling up AI using ML Ops is very important. Now, what is ML Ops? It has basically three stages. ML design, where, as per the CRISP DM life cycle that we saw, it is to do with the first few stages in the life cycle, which are gathering the requirements, the business requirements, the data, and prioritizing the ML use cases, identifying the use cases, and also the data acquisition, which includes the extraction, transformation, and loading. And then we have the model development, which is the core algorithm development, the analysis. It could be a recommendation, it could be a classification application, it could be a regression kind of an application where we are predicting, it could be even forecasting. And all these would fall under the model development, which includes the training, testing, and evaluation of the machine learning models. And then we have operations, which is post deployment. So once we deploy the machine learning models in production in real world systems, we, like we said, we need to have the continuous training, a CI/CD pipeline, more like a one-click deployment of AI systems, the model monitoring, and making sure that as and when retraining is required, this is done automatically. Now that is all about ML operations. So yeah, AI is not a one-man army. Now, what do we mean by that, right? So AI solution, the core may be the algorithm development and the deployment, but like we said, like we saw, the robust infrastructure and good quality data are as important as the algorithms themselves. And the business acumen, so translating the value from AI for business users. Without that, there is no value from AI, right? And this also needs domain expertise. AI can be applied for many domains, but understanding the domain for which we are using the AI solution is also equally critical, right? Unless it makes sense for the domain users, for the domain experts, the insights from AI are not going to be useful. So the marriage between data expertise and domain expertise is as important as the algorithm. So in today's world, so AI/ML cannot exist in silo, right? So there are the maximum amount of value from AI can be derived only through the confluence of all these technologies, which are cybersecurity. So without data privacy, data security laws, we cannot implement AI in real life today, right? We have to abide by and comply with many laws and guidelines which have been laid out for the usage of AI. And then we have cloud or edge computing, which is more to do with the infrastructure. So if the infrastructure is not robust, AI system will fail. And then we have 5G. So from where the data gets collected, it has to be communicated to where the data is being stored and analyzed. So we need communication, and 5G is at the core of that. And then we have IoT, which is to do with the whole connected ecosystem, sensors for collecting the data, and all the sensors talking to each other through the internet. So there are both pros and cons of using AI. Right? So AI has made it very easy for us to do surveillance through video analytics. But there is also a downside to it, saying that sensitive data is being collected for doing this, especially in cases like facial recognition, which are quite personal, right? So not everybody is comfortable with these kind of applications from AI. Then we have automated decision making, which AI definitely enables, but there is also risk from, say, examples like autonomous vehicles. So, sometime back, there was an accident by Uber when there was a pedestrian who was run down by an autonomous vehicle, which resulted in the pedestrian's death. So, there have been cases like these as well. But it only means that we have to use and test AI systems more carefully and in a more robust manner. And then we have yet another problem of interpretability versus complex black box approach, right? So if we use AI, especially deep learning systems, they are not very interpretable or easily understandable for the layman. So there is always a balance that we will need to strike between how complex algorithms are, or what kind of complex algorithms we can use versus how much we can explain. So, yet another downside to AI is the carbon impact of AI. So, it has been seen that training a single complex, large AI model, specifically the deep learning model, can emit as much carbon as 5 cars in their lifetime, which is a huge amount of carbon impact, right? So we will need to carefully evaluate if deep learning is necessary for solving every problem or not. If not, we may have to go in with simpler approaches using first principles, statistics, classical machine learning systems, and so on. Because not every problem would need a deep learning solution. So these are some of the levers which are driving AI adoption today. The first one being responsible AI. So the way we use, for what kind of applications we use AI, for what should we use AI, and for what we should not use AI. So these are being defined as laws today. So there are examples like GDPR, SOC 2, HIPAA mostly for the healthcare sector, which define for what we can and we cannot use AI. And explainability, like I said earlier, the interpretability, having the human in the loop, making the layman understand the underlying methods and algorithms, that is yet another factor which is driving the adoption of AI today. Sustainable AI. Now, sustainability is everybody's focus today, right? We will need to reduce the carbon footprint from whatever technology we use. And especially deep learning systems are compute intensive systems. So there are Data Act, there are AI Act, which are being defined, which are being laid out, which are going to again define rules and regulations around for what kind of applications and how much of carbon emission can happen from AI systems. So then we also have low code, no code, which is again a new trend in AI as well, a relatively new trend, I will say. So since AI has gone mainstream already, AI is no longer a niche technology. It can be used by laymen who do not have too much of a data science experience, data science expertise, or data engineering expertise. So we have AI platforms like AutoML by Google, etc., which can help people use AI without having to code from scratch, right? So this is a trend that has been picking up a lot of steam lately, because this again helps a lot in scaling up AI systems. Yeah, that's all I had. Thank you. Thank you for listening and thanks for joining in.